This week's episode features NanoFe. NanoFe uses nanotechnology to deliver a boost of EDTA, chelated iron. Visit stbiologicals.com to learn more about this and other regenerative ag products. Hello, and welcome to the ST Biologicals Soil Speaks podcast. This week, we'll discuss iron's role in soil health and plant growth. Let's get started. Iron is an essential micronutrient for plant growth and development. It plays a key role in various physiological processes, such as photosynthesis, cellular respiration, chlorophyll synthesis, and defense against pathogens. Iron also influences the availability and the uptake of other nutrients, such as manganese, zinc, copper, and calcium. However, iron availability in soils is highly dependent on several factors, such as soil pH, organic matter, moisture, temperature, and interaction with other elements. Therefore, iron deficiency or toxicity can occur in some crops and affect their yield and quality. It's difficult to single out one soil nutrient when we're talking about the health of the soil or plant growth. The interactions between all the nutrients, microbiology, and the plants themselves are complex and codependent. Soil health is a complex concept that refers to the capacity of soil to sustain plant growth, maintain or enhance environmental quality, and support human health. Soil health is influenced by the physical, chemical, and biological properties of soil, as well as by management practices and environmental conditions. One of the chemical aspects of soil health is the availability of essential nutrients for plants, including iron. Iron in soils exists in different forms and oxidation states, but only the reduced form is readily absorbed by plants. The availability in the soil solution is affected by many of the same factors as manganese availability. The limiting factors for iron include a soil pH greater than 7, organic matter content of the soil, and moisture and temperature. High pH soils or overlimed soils cause iron to bond to other nutrient molecules. These insoluble compounds tie up iron and other nutrients so they are unavailable for plant uptake. We're always talking about getting more organic matter into your soil, and that is desirable. But high organic matter soils almost always suffer from nutrient deficiencies. Ironically, waterlogged soils that have high organic matter and low soil oxygen levels create anaerobic conditions that increase iron availability to plants at levels that may be toxic. But this is highly site-specific. Soil pH is a critical factor. Proper soil management is essential to control soil pH. The soil water status and pH determine whether insoluble or soluble iron oxides are available for plant root uptake. The abundance of microbiology and other nutrients both play a part in iron availability to plants for optimum growth. The interactions between plant soil and microbiology can't be overstated. Moisture and temperature can influence iron availability by affecting soil microbial activity, root growth, and plant metabolism. Under dry soil conditions, iron availability is reduced due to the decreased solubility and mobility of iron in the soil. Under cold and wet conditions, iron deficiency can occur due to the reduced mineralization of organic matter, reduced root growth, and reduced metabolic activity in roots. Many deficiencies and toxicities look similar. It's valuable to maintain soil health and farm profits to understand the interactions of micronutrients, macronutrients, and microbiology. Iron and manganese are two micronutrients that have almost identical plant symptoms for deficiency or toxicity. Manganese and iron deficiencies and toxicities are often related to soil pH and organic matter. However, there are some differences between them that can help to diagnose and correct them. Manganese deficiency is more common in alkaline soils, where manganese solubility is low. Manganese deficiency can also occur in sandy soils with low organic matter, or in soils with high levels of iron, zinc, or copper. Manganese deficiency symptoms usually appear on young leaves as intervenial chlorosis with green veins. The chlorotic areas may become necrotic or brown with time. Manganese toxicity is more common in acidic soils where manganese solubility is high. Manganese toxicity can also occur in waterlogged soils where manganese is reduced to the soluble form by anaerobic bacteria. Manganese toxicity symptoms usually appear on older leaves as dark brown spots or necrotic lesions. The affected leaves may curl or droop. Iron deficiency is more common in alkaline soils where iron solubility is low. Iron deficiency can also occur in overlyme soils or soils with high levels of phosphorus, manganese, or zinc. Iron deficiency symptoms usually appear on young leaves as intervenial chlorosis with green veins. The chlorotic areas may become white or bleached with time. Iron toxicity is more common in acidic soils, where iron solubility is high. Iron toxicity can also occur in waterlogged soils, where iron is reduced to the soluble form by anaerobic bacteria. Iron toxicity symptoms usually appear on older leaves as dark brown spots or necrotic lesions. The affected leaves may bronze or dry up. The differences are subtle and also commonly occur together, both iron and manganese. An excess of either nutrient will cause a deficiency of the other. At ST Biologicals, our highly trained team can tell the difference and recommend the right solutions. Iron toxicity is a function of soil pH and soil water. Re-examine your farm practices and determine how you can decrease soil pH if it's high and improve drainage for waterlogged soils. Our team at ST Biologicals is here to help you solve these problems. Iron is a vital micronutrient for plant growth and development, but its availability in soils is influenced by various factors, such as soil pH, organic matter, moisture, temperature, and interactions with other nutrients. It's important to monitor soil levels of iron and apply appropriate fertilization practices to avoid iron deficiency or toxicity, and to optimize soil health and plant productivity. Manganese and iron show similar, but not identical plant symptoms. These two micronutrients have similar functions and interactions. They require different management strategies. Let's test your soil to make sure you don't plant into a nutrient deficient or nutrient excess field. Optimum soil health leads to optimum plant growth and higher farm profits. At ST Biologicals, our certified crop consultants are here to help you succeed. To learn more about how iron affects plant health, visit stbiologicals.com. When soil speaks, we listen. Thanks for listening, and we'll catch you on the next one.